When you've got what you want.
Okay, lesson 105 is about using proportions in order to solve percent problems. So we've done different kinds of proportion problems. This one is percentages, and what we want to do is take a story problem and put it into a form where we can figure out what the answer is. So let's look at example A. It says 30% of the paintings were portraits. If there were 12 portraits, how many paintings are there in all? Okay, well, I already have my box set up, and I would like for you guys to set up your own ratio box to solve this. So we have portraits, and we have other ones that are not portraits, and then we have a total. So it says 30% of the paintings were portraits. Well, that's going under portraits and 30%. I'm sorry, and percent. So we'll put 30% in there. We always know that our total, when we're talking about percentages, is going to be 100%, unless we're talking about percentages that are greater than 100%, but we're not in this case. So we know what the other must be. It must be 70% because 100 minus 30 is 70. It also says if there were 12 portraits, how many paintings were there in all? So our actual count for portraits is 12. And then we have to ask ourselves, what are we looking for? We're looking for the total. So I'm going to put a variable there. You could have chosen any letter you wanted. I chose X. So what we can do now is set it up as proportions. So we could say 30 over 100 equals 12 over X. Now, 30 over 100 could be reduced to 3 over 10 equals 12 over X. And now at this point we can solve it algebraically by using the cross products, because we know if a proportion is true, their cross products are equal. I'm going to solve it in two ways. Let's solve it that way first. Okay, so we're going to multiply across and multiply across. And so we would get 3 times an unknown number equals 120. Well, in order to figure out what we multiply by, we need to undo this multiplication that's happening with the 3 times the x, and we undo multiplication with division. So now we can divide both sides by 3, because anything you do to one side you have to do to the other, and we find that our unknown number is 40. Okay, so our total number of paintings is 40. All right, now you guys might have thought of a different way to solve it. When we were up here at this step, we could have taken a different tact. I'll just scooch it over to the side here. We had 3 over 10 equals 12 over x. So the other way we could have solved it is to think, well, what times 3 equals 12? Well, 4. And we have to do the same to the top as we do the bottom. And so we would find that when you multiply 10 by 4, you get 40. So that is a different way that we could have solved it. Let's look at our next one. It's example B. This one has to do with sports. Okay? And if anyone's played sports, you've probably had the experience of being a bench warmer, someone who doesn't get to play very much. And that's always can be disappointing. And in this game that it's talking about, only 40% of the team members played. So we're calling those players. 40% played. Our total of bench warmers and players altogether will be 100%, right? So that means 60% of the team sat on the bench. So if 24 team members did not play, so you have to think about, where does that one go? That one is going to have to go by the bench warmers, right? The actual number of bench warmers was 24. The question is, how many did play? So our X goes up there. And so this time we don't even really need our total. So let's set up our proportion, because a proportion is when you have equal ratios, right? So we have 40 over 60 equals X over 24. Okay, and at this point, we can reduce our first fraction. It was probably going to make it easier, right? We can reduce it to 4 over 6 equals X over 24. And we could go lower, but when I look at this, I am automatically thinking about what can make that 6 24. Well, I can multiply by 4 over 4, because 6 times 4 is 24, and 4 times 4 is 16. So I find out that 16 people played, and I can tell you that the bench must have been very big if 24 people sat on the bench. And now if we wanted to, it would be really easy to figure out how many total players were on the team, right? We can just add 16 and 24, and we find out that it's a big team of 40 players. Okay, that's lesson 105. I would like for you guys to finish the practice problems, C, D, E. Those 3 practice problems, and then we'll go over them in our meeting.
When you get what you want.
Lesson 106 is about two-step equations. So we have been doing for some time, we've been finding missing numbers for some time. And I've shown you that when you have an equation and you're trying to find a missing number, what you want to do is do the opposite of what's being done with a variable. So in this first example, we have 3 being multiplied by some variable we are not sure about, and then that equals 12. Well, if multiplication is happening, then the way we can figure out the missing number is by dividing. So a line like this shows division. Now, remember, you have to do the same thing to both sides of the equals mark. And we find out that X equals 4. 12 divided by 3 is 4. Now, you probably could have just done that in your head too. But trust me, things get more and more complicated. So what you want to do right now is form good habits in your algebraic thinking and reasoning. So that's why I try to emphasize actually showing what you're doing. So in the next problem, we have 4 being subtracted from the unknown. So what's the opposite of subtraction? It's addition. So if we add 4 to both sides of the equation, we can figure out what X is. X equals 13. So then you can say, well, 13 minus 4 equals 9. Is that true? Well, yes, it is. So in lesson 106, though, what we're going to do is we're going to have problems where we need to take 2 steps in order to solve them. So let's look at the first example I have is 7 times some number plus 4 equals 29. Well, when you have 2 different things going on, you got to think about which one should I do first. Well, the first thing you always want to do is try to get the variable by itself. In order to do that, you've got to get rid of that 4 first. If you get rid of the 4, then you'll have the 7 times a, and you can take care of that. Well, how do we get rid of the 4? Well, we have to, it's currently being added, and actually I'm just realizing that I wrote the wrong number here. That should be 25. All right, so the 4 is being added, so we have to do the opposite, which is subtraction. So let us subtract 4 from both sides of the equation. Okay, and now we're left with 7a equals 21. And you're probably thinking in your head, well, I know what a is, and I don't have to show my work because it's pretty easy. I can figure it out. Well, once again, we're trying to form habits. So the habit you want is to just be able to demonstrate exactly what you're doing. So what you're doing is you're dividing both sides by 7, because 7 divided by 7 is 1. So now you're just left with a on the left equaling 3. All right, I'm going to do just the first 2 examples, the first 2 practice problems, and give you guys lots of practice problems to work through. So 3 times n minus 1 equals 20. We've said this already. We want to get rid of, we want to get the variable by itself. So we want to get rid of that minus 1 first, and we'll do the opposite by adding 1 to both sides. So now we have 3 times our unknown number equals 21. And now we can divide both sides by 3 in order to get n by itself. And we find that n equals 7. The next one is a similar problem. 3 times n plus 1 equals 16. Okay, we're going to do the opposite of adding, which is subtracting. Minus 1, minus 1. So 3 times n equals 15. Now the opposite of multiplication is division. Remember, that line, like a fraction, shows division, right? And we end up with n equals 7. Okay, so now let's kind of go back and check our answers. So the way we would check our answers is we would take the number we found for n and put it back into our equation. So 3 times 7 minus 1 equals 20. And that is definitely true. 21 minus 1 equals 20. And now let's do it for this problem. 3 times 5 plus 1 equals 16. Indeed, that one's true as well.
When you've got what you want.
Lesson 107 is about finding the areas of complex shapes. We've done this with, we've already done this with perimeter, but now we're going to do it with area. And there's more than one way to do this, as often there is with math problems. We could, actually I've already drawn this. If you'll see the faint blue outline here showing what the rectangle would look like without this cutout here. Okay, if this part were not cut out, this is what the rectangle would look like. And so one methodology, one thing we could do is find the area of the rectangle as if that was not cut out. And then we can subtract the cut out portion. So the area of that rectangle would be 7 by 6, okay? So it would be 7 times 6, which equals 42. And let me look and see, our units are centimeters. So remember, area is measured in square units. So it would be 42 square centimeters. Okay. Another way to write this is like so, SQCM. They mean the same thing. Just means that there's be 42 1 centimeter squares within that shape. And so what we can do now is subtract off that blue area, and that will give us the area of this shape right here. Okay, we would just have to subtract off that blue area. Well, what are the dimensions of that blue area? Well, we have to figure out what B is. So B is equal to 7, this full length, minus 3, the partial length. All right, so that means that B equals 4. And A must equal this side length, 6, minus the partial side length, which is 4. So A equals 2 centimeters. So what we can figure out from that is that this area is 2 times 4. And 2 times 4 equals 8. So we subtract off 8. That is 8 square centimeters, right? And we end up with 34 square centimeters. So I said that was one way to do it. What's another way we could do it? Well, we can see this as 2 different rectangles. I'm going to use red now, and I'm going to erase actually all this blue stuff right here, because now we're going to treat this a little bit differently, and we're going to use red. What we can do is we can treat this like 2 separate rectangles. One here and one there. Get rid of that ruler. Okay, so what is the size of this rectangle right here? Okay, well, we know that this length is 3, and we already decided that A is 2 centimeters. All right, so we know that the area of that rectangle is 6 centimeters, and I'm just going to write it inside of there. The area is 6 centimeters squared. All right, and now we've got to figure out the area of the large rectangle, and that's pretty easy. It's going to be 7 times 4, which is 28. And 8 plus 6 is 14, so we end up with the same total, 6 centimeters plus 28 centimeters squared equals 34 square centimeters. So we get the same answer either way. You just have to figure out a method that you are comfortable with. Both methods work. So how about this figure here? Well, it's an interesting one because we don't have anything kind of telling us what excesses that we have. So what we have to do is kind of figure it out on our own. And again, there are 2 ways to do this, and maybe more, but I'm thinking of 2 ways. And the way you'll learn in geometry to solve this problem is to divide this into 2 triangles, because we know the area for a triangle. And so if we divide it into 2 triangles, it looks like this. We can cut it across the middle like that. And we have a right angle right here. And we know that 6 centimeters is going to be the height for the top triangle. and 6 centimeters will be the height for this triangle as well. So remember what the formula is for the area of a triangle. Area of a triangle equals base times height divided by 2. All right, so for this triangle here, our base is 10 and our height is 6, and we can divide that by 2. So we could divide first if we want. The 2 becomes a 1, the 6 becomes a 3, and our area is 30 square centimeters. And then the area for this one, our base is 14 and our height is 6 again. And we divide that by 2, and we can divide before we multiply. I did the 14 because multiplying by 14 isn't something we know very well, but we know what 7 times 6 is, and that's 42 square centimeters. All right, so now we have the individual triangles and we have to add them together. 30 plus 42 equals 72 square centimeters. Okay. That leaves you 2 practice problems to do on your own, and I know that you will be successful, and you can ask me any questions.
When you've done what you want.
Okay, lesson 108 is about transformations. Okay, so there are 3 different transformations that we will be looking at: rotation, translation, and reflection. So a rotation is basically turning a figure about a certain point. Okay, so you can imagine that you have a triangle. Let's just use a triangle, and it's cut out, and you might be holding it down at this point, and just imagine what it would look like if you moved it over here. Okay, so the bottom has swung all the way up and the whole triangle has moved. That's a rotation. You've got to think of it as like being held down by a certain point and rotated. Okay. A translation has to do with sliding a figure. In one direction without turning it. Running out of space without turning it. Okay, so you have triangle 1 and triangle 2. Okay, the only thing that's happened is it's been slid over. It's been moved to the left, and that is what we call a translation. All right, a reflection is exactly what it sounds like. It's a mirror image or a flipping over a line. Okay, so let's look at the examples that you have. Actually, I think what I want you guys to do is look at A through E and just see if you can figure those out. The other thing I want you to do is I want you to complete the practice page on page 687. Okay, and it's going to be the one related to lesson 108. Okay, because what you can have is you could say rotate something, then translate it, and then reflect it. And you have to be able to recognize these different activities and try to figure them out. They're like little picture puzzles, and they're kind of fun.